Hello, I'm Brian Farrell, and welcome to PACE IT's session on Networking Services and Applications Part 1. Today I'm going to be discussing the basics of the virtual private network, and then I'm going to move on to protocols used by virtual private networks. Now there's a whole lot of stuff to cover, so let's go ahead and begin this session. Of course, I'm going to begin by talking about the basics of the virtual private network. A virtual private network, or VPN, is used by remote hosts to access a private network through an encrypted tunnel through a public network. Once the VPN connection is made, the remote host is no longer considered remote. It's actually seen by the private network as being a local host. There are many advantages to that, but I'm not going to cover them right now. Even though the network traffic may pass through many different routes or systems, it's seen by both ends as being a direct connection. The use of the VPN can help to reduce networking costs for organizations and business. The cost reduction is partially achieved because the VPN doesn't require the use of a dedicated leased line to create that direct connection. There are several different types of VPNs. There is the site-to-site VPN, which allows a remote site's network to connect to the main site's network and be seen as a local network segment. VPN concentrators on both ends of the VPN will manage that connection. Then there's the remote access VPN, which is also called a host-to-site VPN. It allows select remote users to connect to the local network. A VPN concentrator on the local network will manage the connection coming in from the remote users. The remote system making the connection uses special software called VPN client software to make that connection. The third type of VPN is the host-to-host VPN, which is often called an SSL VPN. It allows a secure connection between two systems without the use of VPN client software. A VPN concentrator on the local network manages the connection. The host seeking to connect uses a web browser that supports the correct encryption technology, which is either SSL or more likely TLS, to make the connection to the VPN concentrator. It's time to discuss some protocols used by the virtual private network. The big protocol for VPNs is called Internet Protocol Security, IPsec, which isn't actually a protocol in itself, but a whole set of protocols. IPsec works at layer 3 of the OSI model or above. It's the most common suite of protocols used to secure a VPN connection. IPsec can be used with the Authentication Header Protocol, or the AH protocol. AH only offers authentication services but no encryption. So it authenticates the user, but there is no encryption of the session. Or IPsec can be used with Encapsulating Security Payload Protocol, or the ESP protocol. ESP both authenticates and encrypts the packets. It is the most popular method of securing a VPN connection. Both AH and ESP will operate in one of two modes. The first mode is transparent mode, that is between two devices, as in a host-to-host VPN. Or they can be used in tunnel mode, which is between two endpoints, as in a site-to-site VPN. IPsec implements Internet Security Association and Key Management, ISACAMP, by default. ISACAMP provides a method for transferring security key and authentication data between systems outside of the security key generating process. It is a much more secure process. Then we have generic routing encapsulation, GRE. GRE is a tunneling protocol that is capable of encapsulating a wide variety of other network layer protocols. It's often used to create a subtunnel within an IPsec connection. Why is that? Well, IPsec will only transmit unicast packets. That's one-to-one communication. In many cases, there's a need to transmit multicast, which is one-to-some communication, or broadcast, which is one-to-many communication, packets across an IPsec connection. By using GRE, we can get that accomplished. Then there's point-to-point tunneling protocol, PPTP. This is an older VPN technology that supports dial-up VPN connections. On its own, it lacked native security features, so it wasn't very secure. But Microsoft's implementation included additional security by adding GRE to point-to-point tunneling protocol. Transport layer security is another common VPN protocol. TLS is a cryptographic protocol used to create a secure encrypted connection between two end devices or applications. It uses asymmetrical cryptography to authenticate endpoints and then negotiates a symmetrical security key, which is used to encrypt the session. TLS has largely replaced its cousin, Secure Socket Layer Protocol, and TLS works at layer 5 and above of the OSI model. Its most common usage is in creating a secure encrypted internet session, or SSL VPN. All modern web browsers support TLS. Now, I just mentioned Secure Socket Layer, or SSL. SSL is an older cryptographic protocol that is very similar to TLS. The most common use is in internet transactions. Why? Because all modern web browsers support SSL. But due to issues with earlier versions of the protocol, it has largely been replaced by TLS. SSL version 3.3 has been developed to address the weaknesses of earlier versions, but it may never again catch up to its cousin, the TLS protocol. Now that concludes this session on Networking Services and Applications Part 1. I talked about the basics of the virtual private network, and then I talked about the protocols used by the VPN network. Good day, I'm Brian Farrell, and welcome to PACE IT's session on Networking Services and Applications Part 2. Today we're going to be discussing network access services, and then we're going to move on to other services and applications. As always, there's a fair amount of ground to cover, so let's go ahead and dive into this session. I will begin with network access services. The first network access service that I'm going to discuss is actually a piece of hardware, the Network Interface Controller, or NIC. It can also be called the Network Interface Card. The NIC is how a device connects to a network. The Network Interface Controller works at two layers of the OSI model. At layer 2, which is the data link layer, it provides the functional means of network communication by determining which networking protocols will be used, as in a NIC that will provide Ethernet communication or a NIC that will provide point-to-point protocol. It also provides the local network node address through its burned-in physical media access control address. At layer 1, the physical layer, the Network Interface Controller determines how the network data traffic will be converted, a bit at a time, into an electrical signal that can traverse the network media being used, i.e., it provides the connection to the network. Most modern computers come with at least one built-in Ethernet NIC. Routers and other network devices may use separate modules that can be inserted into the device to provide the proper network interface controller for the type of media they're connecting to and the networking protocols that are being used. Another network access service is RADIUS, Remote Authentication Dial-In User Service. RADIUS is a remote access service that is used to authenticate remote users and grant them access to authorized network resources. It is a popular AAA protocol. That's Authentication, Authorization, and Accounting Protocol. It's used to help ensure that only authenticated end users are using the network resources they are authorized to use. The accounting services of RADIUS are very robust. The only drawback to RADIUS is only the requesters, the end users, password is encrypted. Everything else gets sent in the clear. Terminal Access Controller, Access Control System Plus, or TACACS Plus, Terminal Access Controller, Access Control System Plus. Boy, what a mouthful. It sure is easier to say TACACS Plus, is a remote access service that is used to authenticate remote devices and grant them access to authorized network resources. It is also a popular AAA protocol used to help ensure that only authenticated remote network devices are using the network resources that they are authorized to use. With TACACS Plus, the accounting features are not as robust as those found in RADIUS, but all network transmissions between devices are encrypted with TACACS Plus. Let's move on to other services and applications. First up is RAS, Remote Access Services. Now, RAS is not a protocol, but a roadmap. RAS is a description of the combination of software and hardware required for a remote access connection. A client requests access from an RAS server, which either grants or rejects that access. Then we have web services, creating a means of cross-communication. Web services provides the means for communication between software packages or disparate platforms. It's usually achieved by translating the communication into an XML format, or Extensible Markup Language format. It is becoming more popular as systems diverge. Last up is Unified Voice Services. This is creating a better voice communication system. It's a description of the combination of software and hardware required to integrate voice communication channels into a network, as in voice over IP. That concludes this session on Networking Services and Applications, Part 2. I began by talking about network access services, and I concluded with other services and applications.